In the last video, we learned how to determine the ionic charges for elements in the main groups. So group 1, group 2, group 3A through 3A, all those, very easy to determine the ionic charges they'll form. The metals will always lose electrons to get a complete outer shell. The nonmetals will gain electrons to complete their valence shell as well. We're going to look today at the transition metals, which are a little bit more complicated. Scandium is right next to calcium on the periodic table. It has 3 electrons in its row, so it has 2 in the 4s subshell and has 1 in the 3d. It's going to lose all 3 of those to form a +3 ion. Titanium is going to do a similar thing. It has 2 in the 4s subshell and it also has 2 in the 3d. It loses all 4 and it becomes +4. When we look at vanadium, this thing does gymnastics. It does a whole bunch of charges. It can be +2, +3, +4, +5. Now, the reason it forms a +3 charge is actually fairly complicated, and it's beyond the scope of what you need to know. So let's look at the other ones. It's going to form a +2 ion by losing those 2 4s subshell electrons. That's how it would do that. To form the +3 ion, it will lose all 3 of the d subshells. To form +5, it loses all of them. It loses all its electrons. +5. Manganese. We're not going to worry about chromium. That one's funky. Don't worry about it. However, the one thing you do need to know about chromium is that normally you would predict that it would be 4s2, 3d4. But that's not what happens. The d subshell is actually most stable when it has 0, 5, or 10 electrons in it. So it's either completely empty, half full, or completely full. So it actually shifts an electron from what would be in the 4s to the 3d to make it more balanced, stable, energetically favorable, if you will. Manganese can be +2, +3, +4, actually can be +6 or +7. These ones happen for reasons that you don't need to know. This one, well, I bet you can guess by now, it probably just loses the 4s electrons. To form the +7, well, in that case, it's going to lose all of them. Then it's +7. Iron, that's capable of being either +2 or +3. And you need to know those because, well, again, like I said, the d subshell likes either 0, 5, or 10 if possible. So it could either lose just those 2 and form a +2 ion, or it could lose this other one here, this paired up electron. It doesn't want it. Doesn't want it at all. So if it loses those 3, it would then have a +3 charge. Most of these cobalt, nickel, they form +2 ions. You don't need to know about the +3. That's a little complicated. But most transition metals are capable of losing their s subshell or its valence electrons. Copper, you'll never catch me, copper. You look at this and you're like, that's not how it goes. That's not right. It's all wrong. But the reality is, I said d subshells like either 0, 5, or 10. So normally you would say, why isn't this 4s2, 3d9? Well, it has a lot to gain, energetically speaking, by shifting that s subshell electron over into the d subshell and giving it a complete d subshell. And zinc will only form a +2 ion because it doesn't want to mess around with its d subshell electrons. It does not. It only wants to lose those 2. So that's just looking at the first row of transition metals and giving some level of explanation of why they do what they do and why they become who they are. Thank you.